Okay, 2 minutes to go, but maybe we can start a couple of minutes early. And so let me start by welcoming all of you. I think I consider this a great privilege for me to work with you. This is a very interesting and relevant topic for us, which is how to use Python to do data analysis and data management. This course will primarily focus on showing you how to do things hands-on and practically. So yeah, somebody had asked a question on chat about how long the session is. It's about an hour and a half. And then I can answer questions after that. Does that sound okay to everyone? Or somebody on behalf of everyone can put it in chat. It's about, yeah. So yeah, like I said, I want to be completely flexible here, okay? So if you want, if you think we can stop 10 minutes early, just let me know and we'll see how we can incorporate that. Okay, so like I said, Python and Python for data analysis, extremely relevant topic today, primarily because the interactive exploratory style of programming, which we're going to see today in Python, will make, is very tailor-made for data science and even some business analytics type applications. Okay, so that's what we are going to kind of explore. So once I read the survey responses from you, I will understand more about your learning goals and so on. Okay, so I'm going to jump in now. All of you should log into the course webpage and just follow along. Today we are going to talk a little bit about relational databases and Jupyter notebooks. So can I quickly get a poll here from all of you in terms of how familiar you are with databases and how familiar you are with Jupyter notebooks. So I will, as we go along, I will customize things appropriately. Okay, so a few are familiar, some need practice. Okay, some never access databases from Python. So yes, so today we will actually construct a database and access it from Python, etc. Okay, and Jupyter notebooks. Okay, many of you haven't used it. For those who already know the stuff, everything's going to be interactive. You could open up the notebooks and then, you could explore along. Please jump in with questions or comments. Okay, if you've used something and you know something about it or something has been tricky or difficult, just jump in and don't hesitate to make comments. Okay, so with that out of the way, let me just quickly start with just what is a Jupyter notebook. I don't want to spend too much time on theory, but okay, while I'm doing this, is everyone able to follow along on the course website? Am I clicking through too fast or anything? Is my font too small? Maybe I'll make it a little bigger. Somebody can let me know on chat. Are you able to follow along with the screen? Okay, excellent. Okay, so a small aside here, something that I have been studying for a long time before Jupyter notebooks came to play was this idea of what we call literate programming, right? And the idea was that the world of programming is not just code, but we would like to mix code with, with text at least, and maybe even some pictures and graphs and charts and so on and so forth, right? So how do we do that? Well, that's what the Jupyter notebook has tried to do in a certain way. There is an equivalent in other languages. Okay, so if you want more details, you can look at some of these posts that I've linked to. But now let's get into doing some stuff. You already answered this poll, so don't worry about it. So this is the important thing. Cloud hosted notebook, that's what we want to use for this session, this course. The reason is that then we don't have to worry, like for example, today about installing things and so on. If you want to install stuff locally on your machines and you have a reasonably good machine, then let me know and we can do an install fest or I can give you instructions, okay? So what we want to use is this online Jupyter notebook, okay? So if you click on this link, it should open up something which looks like this. So can everybody click on that link and just follow along with me? There are a couple of tricky buttons to click on. If anybody has trouble, don't worry, just follow along with the class, and then outside the class, we can make sure you can log in and do stuff. Okay, so once you clicked on that link, you can just ignore the survey. The important thing here is you must go and do a sign in. If you want to basically if you want to manipulate the program. So if you click on sign in, you will get an option to sign in. On the course website, I've put a detailed note about what kind of accounts if you don't have an account. If you have a Microsoft account, it should be fairly simple. It's a free service. You can just log in. But if you don't have a Microsoft account, you can just quickly create one. Like I said, this is a little bit of logistics. So if you have any trouble logging in, then just contact me afterwards and we can sort it out. Okay. Anyway, everything I will go through line by line, and this material will be available for you after the class and for the whole course. So you can look at everything systematically. Okay. Can some of you say, you can use, yeah. If you want more details about which kind of accounts can be used, there's this link here. Let me just open it up anyway. It will tell you what kind of accounts you can use, okay? So I'm sorry if that is causing any trouble. Typically, if you have a Microsoft account, you should be in, but you can use other emails, and there's a little bit of stuff here. If anyone has trouble, like I said, after the class, we can look through. Okay, so is anyone in here so far and logged in? Can somebody say, let me know on chat? Oh, good. Some of you are. Okay. So if anyone has trouble, like I said, I want this to be interactive. You can send me email and we can sort it out. Okay. Okay. So once you're logged in, the first thing you have to do, you see this button on the top, it says clone. Just click the clone button. And you should have a screen which looks identical to this. But when you have hit clone, you've got a copy of all of this stuff. So go ahead and clone the site. And then the important thing is you just hit this button which is run on free compute. And this is where the Jupyter magic should start. So as soon as you click run on free compute, you should see this page. Okay. So now let's start by, if you see here, data analysis with Python, there is this intro to Jupyter Notebook. So if you click, everybody clicks on this, you should actually be in a notebook, which is live and ready for us to work with. So can I wait? Might take a second or two sometimes for the virtual machine to kick in and run, etc. And now we should have something on the screen. Okay, lots of clicking around. How many people, or at least a couple of people, were you successful getting this far? Anybody seeing the notebook yet? Oh, cool, cool. Okay. Yeah, it's funny. Clicking a random sequence of buttons in successful order is tricky sometimes, and especially with security in the mix. Okay, I'll give you another 30 seconds before I start. Okay, so let's start now. So this is the arena on which we can do a lot of our coursework this time, but it's also going to become the arena for which I hope today I will convince you that you could use this in future as well, right? For many of your programming tasks. So the first thing is you can see there's a lot of material in here, which is all text. I'll show you how all of this material gets created. You know, you can create notebooks like this for yourself. I will show this to you in a minute. But the most important to get started is you see there's this blank cell here, and it has on the left of it, this thing called in with an empty bracket. So these cells are called code cells, right? As opposed to the cells which contain text, which are called Markdown cells, right? So in a code cell, you have a live Python session. So if you just say 2 + 3 or whatever, it's going to work. Notice for now that to run this, you must hit Shift Enter, not just Enter. Enter will give you a new line. Shift Enter will execute it. And also notice that every time I execute it, the counter on the left, which is this number 2, will actually increment. Okay, later we'll see why this number is useful to us. Okay, but for now we should be able to just run the code in a cell. So far so good. Some of you can unmute your microphones as well if typing in text in chat is hard. Okay, so so now let's go on. So code cell is done, but now let's go and say, okay, just try this, no? So we have to create a cell. You can type in some message. So let's do the traditional, I guess, hello world program. You can use print to do this, right? But I'll show you in a second. So this is typical Python command here. So print something, but you don't need to use print, because actually if I say x equals, let's just take this string here. If you assign something, which has no output, so let me just show you this. If you assign something which has no output like this, and you run the cell, there will be no output. Oops. Yeah, this is just a markdown cell. Okay, so let me just get rid of this cell here. Okay, so if you assign something in a cell, there will be no output, because Python has just assigned it and kept it in memory. In order to see what is an x, traditionally you would say print x, but Jupyter knows that periodically you would want to see what you have just done. So if you just type x and do shift enter, you should have this. Okay. So, okay, I think somebody's decided to cut the grass outside my house. So we're gonna have a little bit of noise for a couple of minutes. Hopefully it'll subside. The real world surprises us all the time. Okay, so one of the things we can do here in Jupyter is to master a few keyboard shortcuts, at least the essential ones. Please let me know if the background noise is too loud. I can always go and try to get it stopped or something. Okay, so there are a bunch of shortcuts. I don't need all of you to learn all the shortcuts. I just put it in the notebook for you to review. If you go to the help menu on the top right hand side, then there's also keyboard shortcuts here and you can explore. Okay, but I'm going to show you a couple of them because they're going to be very useful to us. Okay, so what are the couple of ones? First of all, to execute something, you do shift enter. And then the other one is to know how to edit stuff. Okay, so to edit stuff, what do we have to do? So first of all, you want to create a blank cell. So let me just do that. So I am on a cell, let's say this cell. If I want to create a blank cell, you have to get one concept here. Let me see if I can say this clearly. The notebook works in two modes. One mode is called the edit mode, and the other mode is called the command mode. So if you hit, for example, if you hit escape, so let me click on this cell. You see this cell has turned to green. This is a code cell, and when I click on it, by default, it is in edit mode. If I want to go to command mode, I hit escape, and you see the kind of visual indicator is there's a blue sign on the left, right, which says you are in command mode. Okay, so let's just practice that. So if you click on the cell, it becomes green, it's in edit mode. You hit escape and you're in command mode. Takes a little time to get kind of lock this into your mindset, but many editors, not like the typical editors you might have used like an Eclipse or something, but many editors work in two modes. Okay, and that's because you can do slightly different things in these two modes. Okay, anyway, long detour, but important mental picture: edit mode and command mode, and a visual signature for us. Okay, so now I want to create a cell. If I want to create a cell above, then I can say escape and then just say A for above, or I can be in edit mode, escape, and say B for below. Can everybody just quickly do this so you know how to make yourself cells? Okay, now once you create a cell, by default, all new cells are code cell, because I guess Jupyter assumes that if you create a new cell, it's because you want to write code. So by default, it's a code cell, and then you can just do any Python you want in it, right? So it will do something. Okay, sorry. It will do something. Notice that if I made a mistake, it gives me the output right below there. Okay, so we get code cells. Now let's try to write some Python code, and then I'll come back to markdown cells. So far, so good. Any questions? I'm trying to squeeze some questions out of you. If I'm going too slow, also speed me up. Okay, I will adjust my speed. Okay, so quickly, here is an example of a code cell. I defined a function. I was able to print it out. So this can be a very nice way for you. For those of you who have used Python's interactive shell, this is like an interactive shell on steroids, right? Because you can see it, everything's nicely formatted, etc. Okay, now the next thing is a help that we could all use is like when you are looking at new functions or learning Python packages, it would be nice to know what the documentation might be. So let me introduce you to the first idea. If you say help and pass into help any kind of function, so the string class has a replace method on it. I want to know how it works. If you do help and pass in the string class method, it will print out the help for you. Okay, so that's kind of a nice way. if you do this thing, which is you do a question mark string help, I don't know how many of you are going to like it, then it will pop up a window at the bottom with the same information basically, but it's a pop-up window, and then to get rid of it, you go hit X. I prefer to get my help inline, so I usually use the help command instead of the question mark. You can choose based on your style. And the last thing is, if you actually go and do string.replace and you create the brackets, if you hit Shift Tab, then it gives you help inline, right? It says string.replace takes an old string, etc., etc. Okay, and so, and if it's getting cut off, you can hit the plus button to see more and so on. Okay. Okay, so far so good. How do the notebooks feel so far? You can write code, we can get documentation, we can look at stuff. Okay, so somebody say interesting or not interesting? Not impressed, impressive? I hope all of you are sitting there with a cup of coffee in your hands ready to go. Okay, is anyone on chat? Does it look interesting right now, or you're like, I have my editor, I will just write Python there and I have to convince you? Okay, looks good, somebody says. Okay, good. Okay, so now let's go to the next interesting thing here. I just want to show you that this experience is extensible. So that means there's lots of cool things that can be done. One cool thing is this idea of what are called cell magics. So I'll show you one magic. Very often we write a function and we want to know how quick, how fast, yes, people like it, okay. I'm not selling you Jupyter, but I just want to show you all its capabilities, okay? And then we can talk about, you know, what the editor experience should be and what the future looks like. But today, I'm just happy to show you all the goodies, okay? And if you have any goodies you want to share, just let me know, and then you unmute your microphone, we can talk about it, or you can talk about it. Okay, so there's now this nice little thing. Very often you want to time a program. So there's this thing called a magic. So magic is a thing that you insert on top of any programming cell. It starts with a %. And if it starts with a single %, it means it applies to a single line. There will be magics with multiple % that I'll show you in a second. But if you just run this, it will take a second, but because it is a small function, it will finish pretty quickly, but it runs the code you've given it multiple times and then gives you the standard, the average and the standard deviation of runtime. Okay, so I would encourage all of you to periodically measure the speed of your code, right? It's nice to know which functions are expensive. And I'll show you more of these kind of ideas as we go along. Same thing, exactly similar to this, but with a double %. Then if you have multiple commands in a cell, it will profile the entire cell, okay? So, I mean, relatively easy to get timing. I'm not going to go into prun for today, but I can of course run it. Prun is actually interesting because if you want to know in detail, so this, let's say a function calls another function, calls another function. If there's a hierarchy here, then you could run prun and it will actually profile your code and tell you exactly which function is taking what time. So that's a little bit more detailed for you to look at, but hopefully as you start writing code, it will be interesting for you to know. It's certainly in an industrial strength setting, it's very, very important for us to profile and optimize things as we go, okay? And this is nice to have it once you've written your code, it's very quick for you to just check its performance characteristics. Okay, quick question. How many people, you can tell me in chat, how many of you actually look at your performance characteristics when you write your code, or do you just get it to work and then you're done? Anyone who checks performance? Okay, good, excellent. It's a very important skill, okay? We can spend time talking about, I mean, of course, all of you know, but in data science in particular, there are many, many situations where you start writing code and before you know it, a piece of code takes 15 minutes, 20 minutes, 30 minutes to run. And that's not very good. And it's very often easy to fix if you just take some time to profile your code and understand what's expensive. Okay, so far so good. So now let me show you the next thing. For those who work with other editors, if people want, actually you can just tell me in chat, what other editors have you used for Python at least? PyCharm. Yeah, PyCharm is pretty good, okay? And yeah, anything else? Anyone who has used like Spider or VS Code? Spider, yeah, okay. So yes, so those are great experiences. I'm going to show you quickly that there is a very nice way for you to continue to use your old editors while you work with Jupyter. So for example, here, if you wanted to take this code which you have here, so normally when you work with an editor, your favorite editor, you're going to put the code in a file. So here is a file, it's in this folder called utils, and this file is going to be called test.py. So if I want all of the code in a cell to end up in a .py file, you just use this $write file and give the path to the file. Notice how this cell magic makes it helpful. So this means that from Jupyter, you can be pushing your code into files, and then you can open it up in PyCharm or whatever and continue to work. Now you might ask me the converse question, right? What happens if the code is already in the file? I've made it with PyCharm. Can I bring it into Jupyter? And the idea is, yes, there is a function called %load. So I'm just going to run it. It's kind of a clever little function. It will go and you see that previous code that I had written to the file gets loaded back. The first time it runs, it automatically comments itself out, right? So you don't, so when you run this cell, for example, so this is now executable inside the notebook. But when you run this cell, it doesn't try to reload everything. That's why it comments itself, right? So if you want to reload the code, let's say you edited in PyCharm or something, then you just go back to PyCharm, edit the file, and then just run the load command again. Okay. Okay. Is this anyone going to find this useful, or you're just going to work in Jupyter? Okay, you can let me know on chat. Okay, so then the last thing is, once you've written stuff, so I saw somebody said they work on command line. So I'm going to show you some command line utils as well here, okay? Once you have written stuff, you can, once you have written stuff, you can basically execute. So now notice how Jupyter starts to behave like a terminal. You have this magic called %run. So that's like being on a command line, and you can just say %run and pass the path to a file. And since we have this stuff in a file, it will just execute the file and show you the output of that file. Right? So this is all of the command line stuff that you can do. I will show you a couple of more things. I think I put it here. Let's see. So then there's this little function here. I don't know how useful this is, but in a session, there are many variables that get created. If you want to look at the variables that are live in the session, you can just do this. Right now, I have only just created 3 things. So this is what is available when I run %. Okay, so I just created some variables and a function, and it's nice to have it in one place. Okay, so far so good. Not very impressive maybe, but let's see what more we can do. So first of all, so when we do data analysis, it would be nice for us to have visualizations. I plan to use the last session to talk about visualization because it becomes a topic in itself. And the workhorse of visualization is this old library called matplotlib. And like many of the packages we're going to discuss here, it's got a lot of features. Okay, so it is, anyway, visualization is a little bit an art, but the library is also a little complicated. So we will take, almost a session, and I would love for you to start thinking about kinds of visualizations you would like to do, bar charts, graph chart, there's just a whole bunch of them. So we can go through them in detail. But anyway, what I wanted to show you is you can just run code and, okay, if you run this code, I'm sorry, I should have warned you before I hit the button. On this virtual machine, it takes a little bit of time. In fact, I don't know how long it's going to take. We'll find out. All of you will find out. Okay, not too bad. It may be because I ran it last night. The first time it runs, it can take a little bit of time. And sometimes it even says, I'm building cache and so on, you get a message. From the second time you run it, it should be perfectly fine, okay? And even though this looks rather bare bones, very quickly you can add, for example, if you import this library Seaborn, it brings in all kinds of styles and you'll get nicely styled graphs and you can have different colors and all kinds of cool things. So quick question, how many people are interested in visualization? As I prepare that session, this will be good to know. Somebody let me know on chat. Interesting topic, or no, I just like to crunch my numbers. Okay, very cool, very cool. Overwhelming support, excellent, excellent. Okay, so, but like I said, I want to leave you with a kind of homework exercise, okay? Please start thinking, what is this field of visualization supposed to mean? How am I going to use it? And even if you can start suggesting to me kind of data sets you'd like to explore visually, that will be very helpful to me. Okay, so let's keep the conversation alive. Okay, now just to show you some more kind of thing. I don't want to, notice today, I'm just showing you that I can see the chart in the notebook. I don't need you to understand how the charts are created, okay? If you're just kind of impressed by the fact that you can see a nice colorful chart in line. But okay, I'm not trying to be just entertaining. I'm telling you that we are moving now. Notice how we are moving from a coding world, which Spider and PyCharm does, into a kind of data analytics world where I'm actually building an interactive report, right? So there's a big shift here. But what is nice about this report versus a PDF report is the PDF report, for example, if I put my company's annual data into a PDF report and ship it out, nobody can see how the calculation was done. Or if I'm a biologist or a machine learning scientist and I say, look, I built a model and I predicted something, you cannot do anything to it. But here you could actually share a notebook which summarizes your thought process and everything in a nice narrative, but interleave it with interactive code and with visualizations, right? So it becomes an interactive report. So that's a histogram, for example. And notice the other thing, the number of lines of code that are needed to make something like this is just bare bones, right? It's not very complicated. I don't want to distract you into understanding how to do it. If it already makes sense to you, that's great. Don't worry, okay? In the next class, so I'll just tell you, for example, I've used a library called NumPy, and in the next class, we're going to study NumPy, okay? So in every class, every detail of whatever I put here will be covered. Just to show off something cool, but maybe I will ask this as a question. Many of us have heard of random walks, never really taken one or created one, but here I will, oops. Okay, so that means that for I in, yeah. So you can see that I just created, sorry, there was that's a Python 2 thing. So xrange has been replaced with range in Python 3. But you can see that in a couple of lines, I can actually create an interesting visualization, right? So a random walk is a walk in which, okay, I'll throw in some extra stuff every time in any class. Hopefully I don't take too many detours. A random walk is a very simple stochastic process or a random process where you can imagine a walker who's walking in a one-dimensional space, and every time he flips a coin or takes a random number generator and generates a random number and either moves to the left or right. So if the random numbers are normally distributed, for example, sometimes it'll be positive, sometimes it'll be negative. And so this graph is simply showing you, so the y-axis is actually the way he's moving. The x-axis is basically time. So the graph is showing you how he displaces himself from the origin. And there are all kinds of cool questions about this thing. For those who look at stock markets and stock charts, you can see why this starts to look like this random process starts to mimic the behavior of stock prices. I'm not saying that is true, but it is suggested, okay? And in fact, some of the early work on this kind of stuff, Brownian motion, was done in the context of finance. Okay, long and interesting discussion, but the interesting thing for us today is I could simulate all this in a couple of lines and then we could see what happened, right? So the first time I did this, I was like, okay, this is pretty nice, right? Normally you'll have to open up a charting application somewhere else or write it to a file and open it and so on. Everything's in line, so it's nice. And then of course, I was able to share it with you so you can play with it. Okay, for those who, okay, one more thing here. For those who like other, kind of other languages and so on, this is just to show that other things are possible. So notice here, if you see this kernel drop down here, you see this option to change kernel. You see there are multiple kernels here. And so there's the language F#. I don't know how many I've used. If anyone has used F#, let me know. Anyone? I think more of you might have used R, yeah? Anyone has used R? Yes. So you can actually try it out, okay? I haven't played too much, but I would say to those who use R, the R Studio experience is pretty nice. For those who are interested, we can have a small discussion comparing the R files, R CMD, R Studio experience to this. Okay, because I spent some time on that too. But anyway, it's nice that you could actually switch the kernel right here, and there's all kinds of R to Python and Python to R type of stories that can be explored as well. And the same is true for RStudio. It is also picking up a little bit of Python support. So I'll leave it to all of you to figure it out. But this little code is actually interesting. on the server, there is Node, which is a JavaScript runtime, and then you can actually send something to JavaScript and so on. This whole notebook, by the way, is created using HTML and JavaScript. So there's a lot of extra support for JavaScript, both in the front and behind the scenes. So you can completely customize the experience, write extensions, all kinds of nice things. Okay, so, and now one goodie for those who like shell. So as I told you, this thing is already a shell. So to access shell commands, you can use this exclaim. So for example, you can say exclaim and ls if you are on something that supports ls. If you are on Windows, you have to say exclaim and dir and so on. But your shell commands will be visible from here. For example, here you can explore all this on your own. If you want to change directory, you can say exclaim cd, and you'll even get, like if you hit tab here, it will show you what are the options, just like you would get with any sensible shell. But I am not suggesting you give up your shell. I would not give it up myself. But I'm just saying that if you quickly want to do something from shell, you don't have to switch to shell. You can just run it here. Just use the exclaim. Somebody asked about how to access the web page and code. Is there a link? Yes. So let me just quickly show for those who came in a little bit late. If you go to the course web page, okay, let me just click through quickly. So if you go to the course web page, don't hesitate to ask, okay? Even if you have to take a second, the others will continue to be mesmerized by the notebook. So if you go to the course web page and you click on this thing says Jupyter Notebooks, and then you go to the interactive session, and then here you should find the link online Jupyter Notebook. And if you click on this, you'll come to a sign in page, which looks like this. If you sign in, okay, I'm going to say this fast and you can try it on your own. And if you're still stuck, we'll help you out after the class, okay? Sign in, hit the clone button, and then hit run. And then you will get to a page which looks like this. And then if you click on this link, which says intro to Jupyter, you'll be all set. Hopefully that was a quick review for all of you who did this before. Okay, so please give it a try. If it doesn't work right now, don't panic. We'll get it sorted out after the class and you'll be all set for next time. So you can just follow as I'm doing as well, as I'm showing you things. Okay, any questions quickly about shell commands? Will anyone, okay, quickly, let me ask a question differently. Will anyone use this to run shell commands, or you'll go back to your shell? I'm looking at chat to see. Go back to shell, yes. That's fine. That's probably the right answer, at least in the beginning, okay? But, okay, so for those who would go back to shell to write your shell commands, is it nice to have this capability, or you would never use it? Yeah, it's nice, right? Especially, so here's an example. If you want to install a Python package, you could probably do something like this, okay? So yeah, it's nice. Once in a way, you want to know which directory you're sitting in. It's nice to not have to go open Explorer or something and search for stuff. Okay, so now this is another big topic here for us, but I just want to show you what, so as I said, so this is as much as we need for writing code and generating charts and graphs, etc. Then we can just forget about Jupyter and start working on Python, right? So this is all just Jupyter stuff. By the way, I showed you everything so far just using keystrokes and maybe the mouse. For those who like menus and clicking around, there's all kinds of things you can click around and find your way, okay? So if you like, I'm sorry, I don't like to click around too much with drop-down menus. I just try to use the keystrokes. Let me know, and if you want more help, also just ask me questions, okay? By the way, there's other features like slideshows and so on. So as you get questions, ask me. I don't want to overload you with everything that's possible, but this is like a minimal viable subset, okay? So let's see. Okay, so now to create a report, you have to format things. And formatting, for those who might know this HTML dialect called Markdown. Does anybody know or has seen Markdown before? Probably those who worked in R, right? Our notebooks use Markdown. Yes. So, okay, so this cell, yeah, cool. So I don't have to say much. This cell is a Markdown cell. But notice if you might want to compare the R experience with the Jupyter experience here. There's pluses and minuses. The Jupyter experience means that if you have, so let me just click on this, for example. Here's a Markdown cell. Here's a Markdown editor, right? And the typical Markdown comments, for those who don't know Markdown, you can use single hash, double hash, or triple hash to create headings. You can use star, space, item, star space item to create list elements. You can use $$ to create LaTeX expressions in display mode, which means it'll go in a separate line. If you want it inline in the same line, use a single $. And you can create tables like this. Creating tables is a little fiddly, okay? Just play with it. If you've done it before, then you don't even know. But what is nice about the experience is if I do Shift Enter, it just gets created for you inline. Right, so that is kind of nice. In R, you'd have to compile the document. I think that hasn't changed. I haven't tried it recently, but okay. So you and of course you can compile one cell at a time and see it right away, right? So it's kind of a nice thing to have. And then of course here's another useful feature. Sometimes in your Markdown you want to actually show some Python code or something. So then you just use this triple quote Python. This is all standard Markdown syntax. So those who know Markdown, there's nothing new here, right? Just write your Markdown and go home. So a small thing to show you that, okay, how many of you have used LaTeX? Probably many of you, right? Because you already use R, you probably introduced to LaTeX, yeah. So for those who know LaTeX, yeah, you have reasonable LaTeX support. I think it's using math checks behind the scenes, so it should be fairly standard. But you can write fairly nice expressions and make everything look pretty. I won't delve too much into images, but you can see here that you can actually, it has first class support for HTML commands and everything. So you can actually just get an image and put it in there. It's pretty easy. You can embed notebooks, videos, if you shoot your own videos or you want to link to a talk or something. Here's an example quickly. I'm going to run through this a little fast. Okay, I don't mean to teach you all HTML and JavaScript or anything. Just showing you that you can actually, if you need to extend a notebook, you can just use HTML. So for example, here's a marquee that you put in, or if you want to run JavaScript, you can run it. And then the last thing, which could be kind of cool, but it's little advanced Jupyter, is Jupyter has the ability to be fully interactive. So let's see. So here, so for those who have seen a sine curve before, and you want to understand how does the changing the frequency affect the sine curve, you can make something like this, where you can actually change the frequency and see what happens to the curve. That's pretty cool, right? First time I did it, I was like, oh, I wish I was learning all my math like this. And actually explore it and see what happens, okay? So, but the nice thing is that, okay, I showed you this as exploring a sine curve, but this could also mean one of your users interacting with your analytics, with your analysis, right? You could change parameters and show them what happens, etc. So there's a full interactive experience here, and you can make interactive dashboards and so on and so forth. I think that's all I wanted to show you. Let me pause. Are there any questions at this point about the notebook itself? Then I'll just leave you with some couple of tips about the notebook. Any questions? Don't hesitate to ask. Even if they're comments, that's fine. Okay, maybe I'll also ask the question, how many of you are going to use the notebook aggressively? I'm kind of forcing you to use it because I'm giving you all the contents in here, but hopefully that's going to be a good experience. Okay, some people say for sure. Good, good. Keep using it, okay? This has become kind of, at least in data science and data analysis, yes, good. It has become like a standard. And later I can show you how you can export this to PDF. There's lots of interesting things. And also notice what we did today is kind of cool, right? I just put it on the cloud and shared it. So for you who want to collaborate with each other, you could easily put a notebook in the cloud and then work with each other, right? So it's all kind of nice feature. And it's a free service right now, so use it while it still stays free. Okay, so now a couple of tips. I think to use the notebooks, you should probably learn the keyboard shortcuts. Otherwise, you're going to be fiddling with menus too much. You don't need a lot. Like today, I used just 3 of them, right? A for above, B for below, Shift Enter to execute. Like just a couple of them. Be aware of the different modes. There's an edit mode and a command mode. Then, of course, interactive programming, like we are going to do today, just changes the style of programming, right? I mean, it means that you're not going to spend that much time on big design up front. You're going to start exploring, load up data, and interact with it. The one thing I would caution you on is that the notebook is full of state. There's all kinds of variables created and modified in your notebook. Typically, you should start at the top and work downwards, then everything will be fine. But once in a way, I'm tempted to go back and run something, like I could go back here and just work on this cell and then come down here and work on that cell. But that means that every time you work on something which is above, you are actually modifying state. And so you could invalidate things and create bugs for yourself. The only thing I would say to you is just pay attention to these numbers. So this number says 24 was run before 25. So if I execute this again, at least I know I have tinkered with this cell. So it's become 26 and I know I've changed state here. So I better rerun this cell all of the state is propagated downwards, right? So that kind of in our text files and in our PyCharms and usual text editors, since we run the whole script, it always executes top down. But here you can break that rule. It's okay to break the rule because we're doing interactive programming, but it will cause a lot of bugs. So just a lot of people complain about this. I would say be aware of it and just manage it. Okay. And then if you create large projects with lots of code in it, I don't suggest keeping huge amounts of code in the notebook. I've shown you how to move code out into functions, and you can just import them like I showed you through that %load file, or you can import them as regular Python imports. If you need help with that, just let me know and we can talk about it another time. But it's fairly straightforward. So just move stuff out. And then of course, here's some comments about kind of freezing your environment and so on, but don't have to worry about that too much. So I'm going to switch gears and we're going to do some SQL. So how's everyone doing? Give me some, well, give me something. Tell me, was that fun? Was that too much detail, too little detail, just write something? Okay, good. So at least, yes. Okay, cool. Keep letting me know. Okay, I'm only asking so I can adjust. Okay, and hopefully this can all be fun. Okay, so I'm going to switch to one of my favorite topics. So there are two topics I want to talk about today. One is SQL, and the other is file I/O. File I/O is going to be relatively light. SQL is a thing that I like very much. So we will spend some time on this today. Okay, of course, for me to try to teach you all of SQL today and SQL from Python today would be a almost impossible task. I only plan to highlight some key concepts. So while before I dive into SQL, I just want to say this to you. And if you want it to be otherwise, just let me know. I will try always to give you a strong historical conceptual foundation, because I believe that's how we should build our learning pyramid. The foundation should be conceptual, should be full of ideas and design and all kinds of context. Then we have actual, programming patterns, and the last thing is like syntax. So even though syntax is all important, I don't want these conversations to be all about syntax, because I believe we can quickly learn it if we understand what the setup is. Okay, so that's kind of how I try to channel the discussion. If you guys need or want, and of course you let me know in your survey how you like to learn. If you need or want more kind of syntactical details, I can easily do that. Typically what I do is I give you notebooks, so the notebooks will have all of the syntax for you to practice and so on. While you're building this pyramid, even though everything sounds good in class and interesting, if you have to go home and write some code and practice, there's no substitute for that. And maybe make some bugs and get stuck as well. And feel a little pain, right? There's no learning without pain. So without challenge at least. So embrace the pain and challenge. There's only good things at the end of it for all of you. And of course, I want this course to be all about learning. Okay, so relational databases. Actually, this chapter should have been done after we looked at files, but I'll assume, okay, so let me ask that as a question. Have any of you worked with loading data from files before? I'm sure in R or something, you might have read a file. Yeah, so you have an idea. So that should be enough for me to say that, okay, what happens is that this beautiful work by Cord in the 70s, and there's a link here to this paper, which has become one of my favorite papers recently, because I didn't read it for a long time. I read all kinds of articles on SQL. But Cord quickly realized, and quite a long time ago, that if we start putting things in files, we will actually end up coupling to all of the details of the structure of the data in the file. I'll repeat that again. The structure of the data in the file becomes kind of very relevant to your program, and your program will be broken. For example, if somebody adds a column in a file or adds another item, you can actually break how you interact with the file. So Cord basically spent a lot of time thinking about this problem, and he said the right way to solve this whole problem is to create an abstraction which hides the details of the file storage. And he ended up coming up with this relational model as the abstraction. Okay, so you can read this a little bit more, put some stuff here. But what he's talking about is that what he wants to abstract away is, he wants to abstract away representation independence, right? He wants to get you representation independent. So no matter how, so for those who have already played with SQL, you can see all this has come to fruition. It doesn't matter how the data is stored on file, I want to interact independent of it. It doesn't matter the order in which the data is stored. I want to still be able to interact with it. It doesn't matter how indexing is used as a strategy to speed up things. It doesn't matter how I index things. I still want to interact with my data, right? And he said, okay, we can do all this if we focus on what he called relations. Today we will understand them as tables, okay? But let's see. So he basically focused on this idea that, you know, you can create tables and then you can build a language on top of it. This language has two key aspects, right? One is you define things, so that's data definition language, and you modify things, or data modification language, right? And for us, I kind of paraphrased it back. I'm sure you might have seen this CRUD expression. So create, read, update, delete, right? So these are things that we would like to do. And in SQL, there are commands that do all of them, right? So create, you can use insert commands. There are different create activities, but at least to insert a record, select for read, update to update, and delete to delete. So notice again, something very nice about these kind of abstractions is there's not 1,000 things, different things you want to do. There's just 4 things we have to worry about. Okay, so that's kind of nice. Okay, what else do I have to say? Okay, so we're going to actually try to build a student grade database. I'm going to actually show you, sorry, few minutes of theory. Okay, then we'll start writing some code. Okay, so let's come back to this maybe. Let's go to code. I'm sure all of you want to just look at some code. So let's go back here. There should be, after intro to Jupyter is what we use, there's this intro to databases file. So if you can just open it. So what is my goal? No theory, right? We want to kind of learn by doing some things. So let's just do some things, okay? So student grades, we are going to create a database. But first of all, don't worry about the specific application right now. Abstractly, let's talk about how to connect to databases and what database shall I use. So the database I want to use for this class is this simple SQLite. SQLite 3 is a version thing, SQLite database. And the nice thing about SQLite is that it doesn't require, it's not very administration heavy. You can just create a database locally. It looks like a file for all practical purposes. And then you start modifying and interacting with it. It turns out that SQLite is one of the most widely deployed databases on the planet. So you can look up more about SQLite. It's interesting history there. How many of you or any of you have used SQLite before? Okay, good. So those, and you can ask each other questions and discuss. Okay, some haven't. So the nice thing for those who have is, okay, it's nice to see how we will connect to it with Python and so on. For those who haven't, hopefully I can surprise you how easy it is to work with it. Okay, for those who have tried to work. Yeah, so let me just go ahead and dive in and do that, okay? So the first thing here is you import this package, SQLite 3. I'm going to do everything today at the lowest level, okay? I'm not going to use any data access layer, no object relational mapping, etc. We'll do everything at the lowest level just so that we learn some SQL along the way and it's more transparent to us. Later, if you want, you can ask me those questions and we can talk about all those things, okay? Okay, long story. But let's just run this. And what do we do when we run this cell? Basically, we connect it to this database. So notice, so now let's go through this abstraction quickly. So there's a connect command, and it takes a physical path to a database. And the database is stored locally on the drive. So it's actually a path. And the database file is here, right? Student grades.database. I've already named it. I'll talk about the business problem or the domain in a minute. But you can just connect to this database and you're good to go, right? One good practice in general is always closing your connection after you're done using it. Right now, we're not used it, but we'll talk about what happens if you don't close things and so on. So once you open, so let's open this. Once you open this connection, now you can ask the connection, can you give me a cursor? Okay, and the cursor is going to be the place where we do most of our work. And what does the cursor do? The cursor accepts any SQL command. We're going to talk about SQL also, so don't worry too much, but just understand, let's understand the concept. So we connect to the database, you get a connection object. The connection object has a cursor, and the cursor will take SQL commands. So let's start by doing something, right? So for example, here you can see cursor.execute, and now the first SQL command. So let's, does anybody mind? Oh, okay, I'm just going to just talk about SQL along the way, okay? I won't spend too much time, but if I'm taking too much time on basic SQL and you want to speed me up, just prompt me, okay? So SQL has a first CRUD command, right? Sorry. So the first command is create table. and create table simply creates tables for you, right? In order to create a table, what you need to do, you have to tell SQL what are the column names of the table. And then if you have an index on the table, you can say, what is the index? Okay, so it's easy. But notice this create table is one of those non-idempotent. Idempotent means that you cannot run it multiple times without having bad consequences. So if you run it the second time, it will say the table already exists and fails. So in order to prevent that, you can use this if not exists, right? It's so that you can run it a second time and it won't complain. But if you execute this command, then you basically created a table. Oops. Notice, this is good that it broke. I didn't run the previous one. See, I'm just showing you how the notebook, I went here and ran this, but it really assumed that I ran the previous cell. So now let's just go and do this. And hopefully all should be. If you were running it in order, you didn't see this problem, okay? But notice that the numbers are helpful, right? 3 and 4 make sense. Yeah. Okay, so next thing is, we want to insert. So we've created a table. Now we want to put stuff into the table. So we use inserts. But before I go to inserts, I have to mention, how many of you in Python understand tuples? Or any of you? While I'm looking at chat, I will just say, okay, so tuple is kind of related to structs in other languages like C, for example. But a tuple is basically, the way I would like to say it is, it's a data structure, but it has fixed number of elements, but they can be of different types. So for example, the first element is an integer, the second one is a string, and the third one is a list, right? But once you create the tuple, you cannot add to a tuple like you could with a list. Okay, long discussion there, but probably that all belongs in basic Python. Okay, so you can create tuple here, but I showed you this just so you can play with the tuple and see what happens. But here, I create these variables, which are all tuples, okay? So for example, I'm saying that the first one should be an ID. So here I'm actually creating the ID, first name, last name, date of birth, and an email, right? So that's my tuple. And this tuple structure here matches my table definition, right? If that is the case, then I take all these tuple elements, I put them in a list. So I've now prepared my data. I'm ready to write it to the database. I just loop over the tuples and just call cursor.execute. And inside the execute, I say insert into table. Then I specify all of the column names. And I'll explain why this particular syntax, okay? All of these column names. Notice here is the actual individual student that gets inserted. It's a tuple. And the value structure here matches the tuple structure here. So you could have asked, why can't I just put student right here? And we'll talk about that in a second. But if you run this commit and it works, that means we have actually loaded up data into our database. Okay, quick. Create a database, create a table, insert values. What do you think? Was that quick and efficient, or how has it been with your other experiences with databases? For those who worked in the enterprise, it's like you have to call the database admin, get a login, sign in, blah, blah, blah. I keep prompting you guys to say something on chat. Okay, I will keep going, okay? Okay, so we are able to insert stuff. I just want you to take a second to look at this. This is the other example I gave you. There is a funny XKCD comic here. For those who like XKCD, and just read this thing and see if it makes sense, okay? But long story short, I don't want to dwell on the joke so much, but the long story short is that if you actually put stuff into SQL commands like this, you could suffer what is called a SQL injection attack. But please try to run this and see, actually SQLite takes care of this. It says you're trying to do too many things and it will block you. But anyway, to solve this problem is why we don't put stuff in, we pass stuff in through this mechanism, and then everything gets checked and only 5 values can go in. You can't send the entire SQL through here. So, okay, small detour, it's like a technical thing, so don't get too phased about it. If the joke is amusing, it is. Yeah, okay. Somebody asked about what about the question mark? Okay, so let's see. So let's look at this piece of code quickly. So here is, what is the idea? The idea is I need to create a string. Notice that this whole thing that I've highlighted is actually a string. It's a multi-line string, right? So I need to create a string, and okay, here you can look here. It's multi-line string. I need to create a string and pass the string to the cursor for execution. This string must be a valid SQL string. Okay. Typically that's easy. You can just type it, but here it's a string where the subcomponents of the string depend on which student is being inserted, right? It's a string that's changing dynamically. So I basically need to pull the values out of this tuple and put them into the string, right? And so there are many ways to create the string. The preferred way to create the string is to create a string with placeholders, which are the question marks. So there are as many question marks as there are. So this tuple here has how many? 1, 2, 3, 4, 5. So it has 5 elements and there are 5 question marks. 1, 2, 3, 4, 5. Yeah. So what does Python do when this loop is run? Each time it comes to this loop, it picks up the current student and pulls out the elements 1, 2, 3, 4, 5 and pastes them on the question marks. And then just inserts it, right? If you need more details, of course, ask me a question. We'll take it offline and explore it. Is everyone okay with this? This is foundational, right? So it's a little strange that you have to put these question marks and so on, but think of them as placeholders. Good. Okay. So now what do we do? So then I inserted something. So let's see if it really worked. And so you can run this. Now, what did I do? I created a SQL statement. It said select star from students, right? So I'm selecting from the table. For those who are familiar with SQL, notice you don't have to change anything that you know about SQL. All you have to do is pass it to a cursor, right? And then you do cursor.fetch all, and it brings you all the records in one shot. Now there's a little bit of magic here, but for now we will leave it alone. What is display results? Display results is something I did because I like all of you so much. I saved you the trouble of converting these rows into a nice looking table. We will look at this function, of course, based on your interest. Okay, but notice how nice it is. It comes out well formatted in a table, blah, blah, blah. Okay, so the pleasure of working with SQL in the notebook setup is that you don't need a separate SQL editor and separate display and all that stuff. You just write your SQL commands, execute it, and off you go, right? Okay, so now what happens? When I ran cursor.fetch all, I basically got all of the results from querying this table, the students table. And what did it come back in what format? So what it came back is it gave me a thing called rows. Okay, notice when I do cursor.fetch all, I assign it to rows. So one of the nice things with Jupyter is, if you want to know what is contained in rows, you just type rows in a cell and you run it, right? And you can see what came back. And you see it's exactly the same tuples that went in, right? So it's pretty cool. So to display results, if you didn't want nice HTML formatted results like I gave you, you just show rows and you can see it like this. And if you're happy with this display because you're doing analysis, you don't even have to worry about display results. But what is important for us to understand is that rows are coming back, and that's where all of the data that's in the table is contained. So then I have all these headings here. How did I get the headings, right? The table column name. Well, that goes into a slightly different structure. It's called cursor.description. And it's a little bit of a nasty structure. Notice how only the first element in this setting, only the first element is populated. These are the column names. Okay. So quick programming exercise for all of you Python experts. How do I extract? I would like to have a list of column names. I would like to have a list of column names so I can set the column names in my display, for example. How do I extract the first element of a tuple, which is contained in a list? Okay, and you can look at this list comprehension. I don't know, for those who haven't seen all this kind of style, please let me know, okay, if you want to have a separate discussion on some of these things. I'll just gloss over them now. But don't get stuck and say, oh my God, he did something complicated. I don't know what it is. Okay, please ask. We can easily solve them. So anyway, I extract the first elements and here you got all the column names. Okay. Okay, so far so good. We're making good and slow and steady progress. What have we learned so far? We've learned how to create a table. We've learned how to insert records into a table, and we've learned how to read records from the table. Okay. Now we have to start doing some SQL-like things where we can write queries. I will just mention this, and next time when I introduce you to pandas and so on, you will see more of this thinking. We can do logic in the database, or we can do the logic in Python. And we have to really take some time to think about when do we do logic in the database and when do we do logic in Python. So here, anyway, let's do, today we are doing SQL. So let's just use some of SQL's power here. So you can select and you can put a where clause, first name equals Jim. And of course, instead of giving you all of them, it'll filter, right? So you can use SQL. Like I said, this session is all about saying any valid SQL will work. Just pop it into a cursor and off you go. Okay. And notice I created this nice little function. I'll show you all these functions in a minute, which actually takes a cursor. So the cursor has to be open and valid and a SQL and returns all the results in a table. How many of you like this function? Anyone likes it? Yeah, so what is the function? Yes, so this is something I want to teach you, right? I want to show you that rather than getting the cursor and looping through fetch all every time and manipulating all kinds of things, once you see a pattern, we should wrap it up, right, into a nice little function. Then I can use it all over the place, right? So from now on, you don't have to worry about cursors and rows and fetch alls. You just know that in order to run SQL, I need a cursor. The cursor has to be valid. In other words, the cursor has to be connected to a database, right? We get this cursor from a valid connection. And then you write your favorite SQL and off you go, right? So this is the way I would like you to evolve your code in different situations, right? We'll notice the pattern, encapsulate it into a nice little function, and then we're done, right? So the code looks nice and clean. Look how nice. I'm now working with multiple queries in a Jupyter Notebook. And I can do all kinds of data analysis already, right? Filtering, sorting, all that stuff. So here's sorting for sorting's sake. Like I said, here I'm only showcasing, after I've written execute SQL, there's not much Python going on here, right? I mean, it's all hidden. There's just SQL. So which is kind of a nice thing where we take our code and make it so that we can focus the code that we write only on the business problem to solve, which is creating effective SQL here, okay? So anyway, done. So you can do order by. So now let's just talk about a nice business problem. So pretend that we have a university or I'm running these courses. I have students. So let me just define. So let's keep this on the screen. Let me just, let's not talk databases. So let me just set up the problem. So we have students. There are multiple courses and some students take some courses, some students take other courses. And every course has some kind of grading mechanism. And then there are grades, right? So it's a fairly simple problem. Please feel free to erase this, okay? I just gave this to you to show you how to do some design. Also, let me know if you like this problem, but try to design this in your own way, okay? I think it's really important. This is the part of SQL that a lot of people initially may not do enough of. And so things end up in one table. So we have to have this discussion, but let me just show you the design and then we can talk about this. So first of all, we focus on what are the nouns in my problem, right? So there are students, they have properties. So there's a table for students, seems logical. There are courses. So there's a table for courses. So now it's interesting. I will introduce you to one of my favorite, what I consider one of the hardest things in programming is to come up with good names. So notice I could have called this quizzes, but actually there might be projects, right? So then the things that get grades could not be just quizzes or projects, could be all kinds of different things, right? I could have a seminar which gets graded and so on. So I chose a name here which tries to hide all of that and says it's just some activity which can be graded. But that little sleight of hand is very important in programming, right? Get the right abstraction in place. So, and then once you have graded activity, then you can have grades. So now we have 4 entities. So fairly simple database, right? Students, courses, graded activities, student grades. And now we have to connect them. And now you see that there is this beautiful table that connects everything together. So now the reason why this table exists is because you have to look at relationships. So let's look at first one relationship. One student can take many courses and one course can have many students. So that's a many to many relationship. In this table, keeps the many to many map. So quick question, how many of you worried about cardinality of relations in one to many and many to many? Anyone? I'm looking at chat now. You guys are looking at each other saying, this is all obvious. Why is he taking time on this? Come on, help me. It's a little confusing at times. Okay, no, so don't worry. Okay, the goal here is not to confuse, but to just say there's a concept here. When you have multiple entities, we have to ask about the relationships between the entities, and then correspondingly create the structure that can store the nature of that relationship. Okay, I said that in theoretical words. Now, practically, you have to understand how these tables are created and so on. Okay. If you want, we can have a separate discussion in office hours or offline or something about more details here. But you have to reach out and let me know, okay, either in chat or in email. But anyway, so okay, so now somebody could ask the question, why do I need all this? I could just, like Excel, I could create just one big table, right? So therefore, one line answer is, one of the principles invoked here is that for data integrity reasons, you don't want to repeat data. So for example, if a student is in two courses, if you create one table, you'll repeat all the student information twice. And so then when it comes to versioning and updating, that will cause a lot of headaches, right? So all this design is for good reason. It is to maintain data integrity. But then all this design comes with a cost, which is you have to manage all this and be able to query all this and so on. So it's kind of like all good design, there's trade-offs, right? So I want all of you to understand the trade-offs, right? And your job or your interest or the exciting part is picking the right trade-offs. Okay, so okay, I won't spend more time on that, but now you can start creating all these tables. So I'm going to go a little fast here because now it's for those who know a little SQL, and I've made all the Python kind of easy. Python is doing all the grunt work, but it's kind of become a simple little execute function if you want or whatever. So there's not a whole lot of complexity here. The complexity is all coming from the right place, which is what is my data domain, right? What is a database of student grade information look like? But of course, please come back and let's have discussion, okay? If you can design a simpler database or make it look cleaner, let's do it. And then maybe next time we can show it to people, okay? Yeah, if anyone wants to tell me, how do you like this data structure? Is this what you would have come up with, something like this? Does it feel very complicated, or does it feel like this is how it should be? It feels like I would have designed something like this. Anyone? Guys are not very chatty. Is it because it's early in the morning? Okay, some of you like it at least, right? Okay, don't worry. Okay, if it's difficult, yeah, some of you like it. Okay, good. I'm encouraged. At least some of you are on the same page as me. For those who feel it is difficult, don't worry. Okay, some of these things we can discuss more, and it will get more clear. Okay. So now just go ahead. You can run all these cells on your own. You know, create the tables for you. But now once we are okay, so this table is probably interesting, right? So in this table, notice how one of the important things with data, playing around with data, is that you have to create data so you can test out all your code, right? So you have to simulate the data, which is what I'm doing, right? Right now I did it in a very dumb way. There are very clever ways of doing all this, okay? Where you can artificially generate thousands of records and so on. But right now, for the first session, I just did it by hand. So you can start thinking about how can we simulate other problems and create larger data sets so that I can test my code, okay? Also, another way to do this is you get data from some source and then you load it up in your data tables, okay? Then, of course, you don't have to create the data, just write a load program. But the load program looks like this. Maybe the data comes to you in files or from a website or something, and then you just loop through that data and enter it into your database, okay? So we'll cover the files later, so we'll be okay there. So now, anyway, so now once I run this, hopefully I'm running everything in sequence. When I'm talking, I'm not disciplined, I guess. So if you run this, now you should be able to select from the courses, right? If it all went through correctly, yeah. And you see that the data has been faithfully entered into the course table. So all these courses here are for you to run, to create other tables. So notice the entire database is being created here cell by cell, okay? So that we can explore with this. Later, what you do is you take all of this and you put it in a Python script, and you just execute the script and the whole database will get created and populated, right? So it will be just one function, one script that gets run, and you have a database. I have actually done this for your programming labs later, okay? So but anyway, you can start visualizing all this. So here we've inserted data, but now we come to the next important concept, which is joins. So of course, like I said, I apologize. My intention is not to teach you SQL, maybe just make you feel familiar with it. We must spend a little time if you don't know SQL just to read it. The only thing I would say is SQL is fairly easy because it has only a few concepts. So what I've done for you is I've pulled out the essential concepts you need to know, like for example, insert, right, or delete. Now we're going to the next, kind of the biggest concept, biggest thing that people wrestle with. The favorite for all those who are going to go to interviews. If you say you know SQL, you're going to get some kind of join question. So you might as well know join. So what is the problem here and how do we solve it? So the problem is that I want to get information about students and which courses. Okay, right now I just want the course ID. Notice that some students are in course 1 and some are in course 2 or whatever. And they don't have to be the same. Depends what the data is. But that's important that I need to know student information and course information. Right? So first thing I do is there's this table called student in course, and I'm going to join it with the students table. And so this is a keyword we're looking at. It's called join, and there are different kinds of joins. So if you want me to talk briefly about different kinds of joins, just let me know, and then we could spend 5 minutes next time. Okay, but for today, I'm going to assume you're all join experts. So there's this thing called an inner join. So the inner join is basically an intersection. It will give you the common elements between these two tables, right? So I get the common elements between these two tables, but how do I check something is common? Well, I check something is common by checking if the student in course ID matches the ID in the students table, right? So whenever you have a join, you must tell me what is the key that I should use to check for equality. And that's it. Then we are done. We should get data from 2 tables. Can I do this with 3 tables? The answer is yes. You can keep on joining. So after I've created a 2-table join, I can add the 3rd table. So now I have students in course, and now I have the courses table. Again, when I insert the next join clause, I have to say what is the key that I want to join on. And here I'm using the course ID and the course ID. Notice that when I created my tables, I gave kind of sensible ID names. So it's kind of easy for you to type this, right? The keys have the same names. So it's kind of, it's just the key is living in a different table. That's all, right? So once I've done this, now I have a 3-table join. Already that's like a SQL. We're getting into SQL power clauses, right? Once you do 3-table join, it's harder than 2-table join because you get 2 clauses, right? And then of course you can sort it, right? So order by, and then you get your stuff. And see, notice the course ID has now been replaced with the course name, which is what I was doing the 3rd-table join for. Let me pause. How is everyone feeling? Anyone want to tell me? All good, easy? Oh, thank you. Okay, so you're doing good. So the goal, is anyone doing not good? Okay, I don't need you to put up in public that you're not doing good, okay? If you have any questions, of course, please reach out to me, okay? Don't get stuck in a corner saying something is difficult. And of course, for those who are advanced, I encourage you to keep playing with these notebooks in class, right? Write your own code, make your own database. Just leave this audio on so you can kind of follow along. But of course, if this is too easy for you, just let me know. Okay, I can always make things harder and so on. I want to tweak the course based on your experience. If it feels right, also let me know. Okay, so the rest of this is just, let me just go through slowly. These are just more inserts, inserting more data into different tables. Now I'm actually inserting grades into tables, etc. Right? And whatever. So you can delete stuff. So that's important, right? So let me just introduce you to this concept. So this is a dangerous concept because it's actually going to delete data. So be careful when you run this command. Typically on databases, make sure you've backed up stuff and so on. So anyway, you can execute delete as well from it. So this will delete all records in a table and so on. Okay. Like I said, for those who have used SQL before, this is a nice place for you to, I always wanted a place to practice writing SQL. And it was always hard because I had to create some big database and so on. This has become extremely lightweight and easy for us to do, right? So they should be I remember my first database course and I came home and everything was theoretical and I couldn't get my hands on a database. So that was not fun. So now you have no reason to shy away from playing with database. databases. I will make one comment here, which is very important. Right now, as I have shown you, there seems to be two worlds, and this is a foundational structure, right? There's a world of data, which preferably wants to live in data structures like databases. And then there's the world of programming, right? Where we write, logical code and iterative code and so on. And the skill here is how do we mix the two in a good way, right? So one way, the traditional way has been put all the data in the databases and use the database tool and then just pull things out of the database and manipulate in your program, right? And so the data lives in the data world and programs live in the program world, and then somehow we connect the two. There's always been some friction in doing that. For those who are more advanced programmers, that is something to think about, and we can have a lot of discussions about how to bridge the gap. The more effectively we bridge the gap, the better our code becomes and easier it is for us to do our work. But when we get to pandas, I will show you a slightly different way of doing it. When we take all the data, just use data stores as dumb things, we pull all of the data into our code, and then we manipulate everything in code. So rather than writing SQL on a database, we will write SQL on our code. So everything will run in memory, etc. But that's for another day. Today, I encourage all of you to just play with this. Okay, so I don't want to beat this one to death. Unless you want me to run anything. Can we just take a minute? I'll take a minute pause just to look at the notebook itself. Just more and more joins, that's all is in the rest of the notebook, okay? So if you want to, if you can do all these joins correct. So the way I want you to use this notebook is run it, of course, see what's happening, then delete all the code and write these joins yourself, okay? See if you fail, if it breaks, etc. There's not much, conceptually, there's not much going on. Yeah, I think this is the, yeah, there are some powerful, like this last join is, by the time you start writing SQL like this, you're all set, okay? And of course, I want to also take you back here now quickly to the picture we drew, making this kind of picture to model your domain, whatever business problem you're trying to solve, analysis problem you're trying to solve, whatever app you're trying to create. Getting the business domain modeled and quickly summarized like this is very nice. So what I try to do today is give you a flavor of what that feels like. Okay, usually that's hard to get, but I think already with 4 tables you can see it's not trivial at all. Okay. Okay, so then let me switch gears. Let me pause for a minute. Any questions or comments? You're such wonderful students. You don't. You don't cause any trouble. No, but please do ask some questions if you have any. You can also just unmute your microphone, okay? So if you don't have to type. No questions? Or is everyone looking at the notebook? Okay, so then let's just switch gears and then let's open up the last file we want to look at. So this is the file here which says file IO with Python. Okay, we'll just wrap up quickly. I think we have a few more minutes, so they shouldn't take too long. Okay, I just want to caution you on something. If you feel I make something look deceptively simple, there are some tricky corners in all of these things. So, you must kind of think on your own and ask questions and so on, okay? Okay, so file IO. So what is the idea now? So now we come to this idea that, okay, we have things in programs, and programs usually have a life. They run and they complete. So whatever all the state and the data and all the good things that we have in our programs, we would like them to live on beyond our programs. So what we have to do is we have to persist, right? Persist our data. And we just looked at this idea of persisting data in databases. And I told you that databases were created to prevent some of the problems of persisting data in files. But having said that, now we'll go and see what can we do with files. The idea here is to quickly show you what we can do with files and show you that it's not very complex at the moment. But of course, we will use more powerful tools to access files in the next session and so on, right? So right now we'll go to lowest level Python and just open files and start doing things. Okay, like all things, there's a hierarchy of ideas here. So files have formats, right? So they actually tell you how the data is stored in files. But before we get to formats, you have to also understand that there are things called character encodings. Notice that these are all, each of these can become a very complicated topic. So for example, understanding Unicode, the Unicode standard is a little bit of work. Okay, but I'm assuming that you covered all that in your intro to Python courses or whatever. So I can just assume that at least the concept is understandable. So there are formats, there are encodings, and then there are kind of lines and line breaks, right? So this is I mentioned this. You can think of it as a format thing, but lines and line breaks have all these things that they depend on the operating system naturally and so on and so forth. So you might have to deal with this at some point. So notice already I'm telling you this is why working with files is not much fun, right? In general, we want to focus on the business problem or the analysis problem and not worry about line breaks. But if you start working with files, especially in multiple platforms, all this will become very relevant. So we want to hide all that stuff. Okay, typically when you have data and there's multiple elements of data, you want to separate them. So you have comma separated files or tab separated files or whatever separated files, right? So, and we need to be able to parse all these different kinds of things. So in general, you will have to parse a file, okay? The other thing we can expect with files is there are header rows. Usually header rows are used to tell you what the content of the file is. Some people have used other types of files where they put header rows in separate files and so on. But in general, there may be, okay, so that's a conceptual point, right? For every data, there is metadata. And metadata should tell us how to use the data, okay? Okay, so all theory. Now we want to write to a file. So what do I need to know? Well, first you need to know which file I'm going to write to. So here right away, let me put a disclaimer. The entire story of directories and files, how to navigate directories, how to navigate folders, etc. It becomes a Python topic. If you need help, let me know. I can incorporate something here, but that becomes a fairly elaborate, I don't know how elaborate, but yes, you want to know if a file exists before you try to open it and so on and so forth. But for now, let's assume that we know how to navigate folders and directories, fairly easy, but we end up with a name, and preferably the name we know as a path relative to where I'm sitting right now. Okay, so now you can see why file names and paths become a separate story on their own. For now, for this code exercise, just to create a little bit of structure, I have a folder on the thing called data. Let me see if I can show it to you somewhere. Yeah, I guess if you click on this, you can see that there are folders here. So if you click on the data folder, you should see there's stuff in here. This is where I put the database and so on, right? So there is some structure here already of, it's not just everything is in one flat location. That's probably what the world looks like, right? But anyway, so the file name is a path which ends in the actual name of the file, right? So in this case, I want to write some data. I just created a list of 10 numbers. I want to write it to this test.csv file. So how do I do that? Okay, so how do I do that? You need three concepts, right? First, you have to open a file. Sorry. Then you have to write it, and then you close it. That's it, right? So when you open a file, you have to choose what mode you want to open a file. So there's a mode. So when you say open, you can, if you put your cursor here and do Shift Tab, it should give you some help as well. So there are lots of other kind of power things which I'm not using, right? All I'm using is this idea that when I open the file, there's a mode, and I put the mode to be write because I want to write data. W for write, R for read, right? So that's it. And then here, just to show you what happens when I call open, I basically get a handle, okay, which I can then use to do my work, right? So I suggestively call it file handle. And now the work becomes actually very easy. Once I get a file handle, all I have to do is call write. So you can think of write as an analog in some sense, concrete sense. You can think of write as an analog of print. Everything that you would call print on, here you can call write on, right? And every structure that you would see with print, you would simulate with write here. Except that instead of showing up on the terminal or in Jupyter, it'll go into the file that is open. That's it. And that's the long story of writing to files, right? Done. So if you write this and then if you go navigate, I won't open it right now, but you can navigate and check. That's all for you to play with, right? Change the data, write all kinds of cool things, okay? One important thing is make sure the file handle is closed. So this is now just to show you that that simple instruction can be complicated. Yeah, you'll say, I'll never forget to close it. But of course, what we didn't handle here is that if this code which was in the for loop had an error, then your program could crash and you could leave the file open. And then when some other program tries to open it, you could have trouble. So in general, you need to make sure that you close things. So now, I don't know, let me ask, has any of you used context managers in Python? Notice I'm using a lot of Python goodies casually. Anyone has used a context manager? Sounds very complicated. Can somebody who has used it? Okay, no. Okay, at least some of you haven't used. So let me just say, so this idea is very simple in Python, okay? The idea is when you want, so I want to open this file. I want to store this value in the file handle, and then I want to do some work. But I want to make sure that when I exit this working space, so when I'm writing code further on here, then I want to make sure that whatever I allocated, so whatever resources I allocated, whatever context I created is automatically destroyed. So if I write code like this, I have to physically call file handle.close. But if I do with, and then after the with, I'm setting up my context, okay? So with this context, do the work. And then when I'm done with the work, Python will automatically clear up the context and deallocate all resources. So like I said, it's an intro to Python question, but it's a very powerful intro to Python question, right? I mean, it's a pattern, at least for now. For files, you can just use it like this, but you can start to see whenever you allocate resources. So for example, in the previous case, when we allocated the database connection, you could allocate like this and then use the context to take care of everything for you. Very powerful. Try to play with it. Maybe you can browse some discussion of context managers in Python. Come back with questions. Okay. But to proceed. So, but anyway, if you don't want to use context managers or whatever, you can still write code this way. Then I would suggest if you're going this way, you should put a try catch block around this. Again, exception handling is important, right? So just make sure you choose a style and use it, okay? Context managers are relatively new in Python, but I like them. So I just wanted to share it with you. It makes your code look kind of nice and clean and takes care of everything for you. Okay, next important thing, of course, as I told you before, as soon as I see this pattern, I tell myself, okay, I'll be writing the files very often. I don't want to deal with all this stuff. I just want to have a file name and some data, and you please write it for me, right? So you make a quick function like this, and then you can forget about all this stuff, right? You'll just call write file, give a file name and whatever data you have, and your work is done. The inverse of the writing process is the reading process, and it has the same idea, right? You basically take a file name, you set up a context, and then you can iterate over the file handle, which is kind of important idea now. The file handle is a stream of data, so it's iterable. So you can use a for loop to go over all the lines in your file, right? So you say for line in file handle, and I can either print it or I can add it to a data structure. In this case, I'm just going to add it to a data structure. So if I say read file and pass in the file name, which happens to be the file we just wrote, then I can read it, and because it's Jupyter, I can even display it. Right, nice and easy. This is the print part, and this is the display from the data call. Okay, and just for practice, there's a slightly more elaborate file here that I've created for you, but you can see it tries to simulate company returns for a year. So you can start to see how I can make the data look more realistic. Just, I don't know, show off the capabilities of Jupyter. We can just say something like this. And let's see, what can we do? So if you see here, I created this little display helper. Let's see if it's going to help us here. So if I say display, so let me just do this first and then work backwards. Notice how I got a nice little table of company results. So this is the kind of problem that I want all of you to understand. How does this work? Okay. So let's go and look at display helper. So I can just load it up here. And I want to say that what I had to do to get this nice little table output, this is where Python programming. So I'm not teaching you guys Python programming right now. if you need help in these topics, let me know. I'll figure out what we can do, but I'm focused on the data part, okay? So this data is all in a file, and I created a little function so you can read it on your own. But what this function does is it creates for each row in the table, it creates a small HTML string. And then because I am in a Jupyter Notebook, I can display the HTML table. So I basically created a HTML table. This is the code that displays the HTML table. I've created an HTML table from my data, and then I can have it formatted any way I want, and so on and so forth. Okay, I've not done too much formatting, but you can see how this all works. Again, I show you this code only to tell you that if you can think of the problem in the right way, you can manipulate your data, write little functions, utility functions like this, and then you just don't have to worry about all these things, right? Once I create display results, I don't have to worry about HTML or formatting. But in order to clear display results, I had to understand something. So what did I have to understand? I had to understand that there are rows and columns. And so if I can extract all the rows in a data structure and all the columns in a data structure, then I can create a header row with all the column names in it. And then I can create all the actual physical rows with the row data in it. And then we're done, right? By the way, I promised to show you what this execute SQL was. Here it is. It's just 3 lines of code. So this is the one that I've been using earlier on. Okay, so okay, I think we covered everything, and we're almost at 9:30, right? So we even made time. Okay, can I pause for a couple of minutes? Questions, comments? Can you guys unmute your microphone? I'd love to hear your voices. Shall I try to unmute all? Okay. Okay. Any questions or comments? How is the course? Was it difficult, easy? Is the discussion at the right level? Anyone? Okay, a lot of you prevent. A lot of you like the chats. Okay, I'll watch the chats. I would love to just have you ask questions and make your comments by voice too. But okay, chat may work. You may not be able to talk in some environments. Okay, it's fine. So let me just say the following. There is a lab on the website for us to do, but I don't want to give you all labs in the first class to go home and submit assignments, etc. So how about we pick that up next time? There is a lab just to practice all this, exactly the same data set, the same tables, and I'll show you how to do the labs next time, okay? By labs, I mean the projects, the code that you can submit to me that I can grade for you. For this week, I would love for all of you to play with the notebook for sure and play with some of the SQL stuff. And please, I have put some contact information on the website, so you can send me email. I will follow this up with an email certainly tomorrow or latest by the weekend, just with any follow-up items. In the meantime, please don't hesitate to ask. I'm here to support all of you, okay? You are the stars of the show. I'm just here to help and, make you all successful. So what I need from you is that you ask questions. Don't let yourself get overly challenged by anything. There's always a simple way to look at stuff, and there are no bad questions. Okay, and then of course, please make sure that you plan some practice time. The best thing to do is just like you put this class on an 8 o'clock calendar, put an hour or two of practice onto your calendar and create a habit of simply sitting down and doing some analysis. Okay, and I will try to get more and more interesting problems as we go along. I'm happy to pick up problem suggestions from you. So if you have a data set you want to analyze or a particular data topic you want to explore, just mention it to me. Okay, and then I can look at how to incorporate it. Okay, so with that all said, I want to thank all of you. I'm really impressed that you're putting this effort. These skills will be very valuable to you. And I'll see you all next week. And in the meantime, we'll be in touch by email. Okay, thank you very much.